Welcome again to Chem 230, Introductory Organic Chemistry at Glendale Community College with Dr. Bob Blake. And we're about to start the second review part of the course. So we looked a little bit about atoms and electron configurations and where electrons sit in atoms. And that's really important as a starting point for understanding the world and the things it's made of. Now we're going to get into a little bit of how atoms interact with each other and how we can predict the types of bonds and describe the bonds in molecules. So good reading assignment is here. Chapter 1, we talk about Lewis structures, single, double, and triple bonds, some example molecules, and a little discussion of hybridization, which is probably one of the more complicated things we'll do this semester. The ultimate review we're going to have, which probably isn't a review for most people, is a valence bond description of molecules. And that'll be challenging, but it's a way to look at bonds formed between atoms. So I start with a little intro to the valence bond ideas, which we're going to be moving towards as we go through this section of the course. And atoms bond to each other because the resulting structure is more stable. And another way to say more stable is it's lower in energy. A bond is defined as a shared pair of electrons, and this is a really important idea, that a bond is a shared pair of electrons. And the key valence bond theory part of this is overlap of orbitals results in a bond. So we talked a little bit about orbitals and what their shapes are and where they come from. And the reason that they're so important is because if you understand where the orbitals are and where they're directed to, you can see when they'll overlap and when you'll get bonds. So valence bond theory, key idea is the overlap of orbitals results in a bond, and that creates a physical space for a shared pair of electrons, which when between the nuclei help pull the nuclei together. So a simple example of that is if we took hydrogen, which is super simple atom. All it is a proton in the nucleus and an electron that's outside the nucleus acting as a wave. And if you drew a little orbital, this would be the 1s orbital is this spherical shape around the nucleus. And the other hydrogen atom would also have a nucleus in the center and a 1s orbital. So hydrogen atom, cartoon picture looks like this. Hydrogen atom, cartoon picture looks like that. And as we bring the two hydrogen atoms together, then their outermost orbitals start to interact with each other. So there's the overlap between the 1s orbital on one hydrogen and the 1s orbital on the other. And that'll mean that there's more electron density that will be drawn into this space between the two nuclei. And that electron density between the nuclei helps draw the nuclei together, helps keep things more attracted. So you can envision if you had two negative charges here, then these negative charges would bring the nuclei towards each other. In terms of an electron energy diagram, the 1s orbital is at a certain energy level, right? And each of these would have one electron in them. When you create this physical space between the two nuclei, that is going to be called a sigma bond, and we'll get more into the terminology later, but the sigma orbital now has space for two electrons, and this orbital is lower in energy than the original 1s orbital. So an electron in this 1s orbital could see one nucleus in its environment. An electron in this sigma orbital would be able to see two nuclei and it'd be more attracted, more stable, and lower in energy. And then when you designate more of the space between the nuclei has room for 2 electrons in a more favorable spot. There's also what they call a sigma star orbital, which is the space on the outside of the nuclei, which is less attractive, and electrons won't go in there because it's higher in energy, and that's why you form the bond from the overlap of orbitals, but you don't put any electrons in the what they call the anti-bonding orbital. So this is going to be way more advanced than we need to understand, but I want to give a little picture of, first pictorially, how you see 2 atoms with their respective orbitals, and when they come together, this area of overlap provides a nice space for 2 electrons, and that space is lower in energy, so the 2 electrons going into the bond is lower in energy than the original electrons were in the individual hydrogen atoms. So, super cool little introduction to valence bond theory for us to think about.